Alrighty, I'd like to just give you guys kind of the abridged version of rotations. So, a rotation really in geometry is establishing a point you want to rotate around, like Q, and then taking that object, that pre-image, and just kind of taking it and moving it around that pivot point. We're used to rotations like maybe the letter T. If you pin it right here and you want to spin it this way, it does that. But this point doesn't need to be on the figure itself. You can rotate around something and be a distance kind of from it. But yeah, we see the same things. We see the image is right here, and we see its pre-image right here. And we see something a little new here is an amount that we rotate by. It looks like maybe like 40 degrees. Okay, so that's gonna be central when we use the notation, is we're gonna list how much you rotate by, what you rotate around, and of course, what is it that you're rotating? In this case, it's a triangle. Okay, so to practice kind of spinning some points around the origin, this was a good graphic in the textbook. So if we're right here to start, in the first quadrant, this is Q1, this is Q2, Q3, Q4. We can take that point and spin it 90 degrees against the clock, counterclockwise, and that lands us at -2, 3. If we spin it another 90, we get to -3, -2, and if we spin it again, so we're a total of 270 degrees, we would be at 2, -3. Okay, and rotations, if not stated otherwise, are performed counterclockwise. Okay. Let's do a standard question here. So if we got E at 1, 4 and F here, and they asked us to rotate 90 degrees, and that O stands for the origin, which is 0, 0. So that's where we're spinning this around. And we got to rotate it 90 degrees. So we're going to take E and bring it over here. So how do we do that? My best advice is to draw a little L shape that reaches the point from the pivot. And we're going to spin this down here. And that's where E is, or E prime. So it's like this rigid, because it's a rigid motion, this rigid L shape, and you're just spinning the L, and that kind of helps track the point. And we could do a similar thing for F, have a bigger L here, and spin that L this way. And the L, which is a 2x5, would land us right here. So this is the image. So if we erase all of our stuff, we get the rotation. So it's almost like they just took this entire box and just spun it over here. You could think of it that way too. And then of course we want to label the points. So let's take it slow here and write down the original points and where they went. So E prime ended up being at -4, 1. F prime was at a -2, 5. So for the coordinate rule, we want to take a look again and see how did the generic point move. And we can see here that the 1, it moved to the end. And the 5 that was in the X position moved to the end. So this is going to end with X. And the 4, the Y, ended up moving up front, didn't it? And then we slapped a negative sign with it. So that's why the rule for rotating 90 degrees around the origin is that. Okay, and that'll be given to you. Let's try another one. So we got -2, -1, and -6, -3. Okay, and we want to rotate 180 degrees, which is half a turn around the origin. So I'm going to still make I'll show it for B, but I won't draw out the whole thing for A. So basically, make your L shape to get to B, and then we have to rotate it like kind of twice, 90 degrees twice. So we're going to take this and spin it over here, and that L goes all the way to the bottom, and it goes over 3. Okay. And it also will spin again, another 90, and that'll total 180, and it'll land us right here. So that's where B goes, right here. And A, a similar kind of spin, you could figure out that it goes first to here, and then it goes up to here. No, that's not right. I'll go ahead and draw it. It's hard to see these things. We got that little L, this little L, and then it goes out 2 and up 1. There we go. There we have it. That's the turn, just like clockwork. Okay? Again, we have to slow down. If we want to get a generic rule, we should pay really close attention to what happened. So let's write down all of our points. Okay. Where did this stuff go? Well, A prime went to 2, 1, and B prime went to 6, 3. So this is an interesting rule. The rule here is to just multiply everything by -1. Because if you do that, see how like the -2 became a 2 and the -3 became a 3? That's because you multiplied by -1. So that's the rule for 180 degree spin. Okay? If you ever see 270, it's kind of overkill, right? That's a lot of spinning. We can actually shorten it up, because if you were a point here and you wanted to spin 270 degrees, you're going to go all the way around here and land here, right? Well, there's an easier way, isn't there? Couldn't we just like imagine doing this? So this is a 90 degrees clockwise spin. So when you see 270, I'm probably going to end up doing a 90 degree clockwise, just because it's going to save me a lot of time and effort in sketching. So let's plot this. Okay. All right. You know the drill. We draw our L shape. And you can draw it like that. You can draw it like this. It doesn't matter. Just draw an L. And then we're going to spin this way. You see? We're going to spin that way, clockwise, like a clock. It's like you're moving from 12 o'clock to 3 o'clock. Okay? So what is that going to do to the L? It's going to spin it, and it's going to go like that. And that's where C prime is. Much easier than having to draw all those L's. We go out 5 and over 2. And that is D prime. So very interesting looking, if we erase, so picture this, copy this if you need it. I'm going to erase it. There. Kind of a little tougher to see. If we were just asked like what happened to this figure, we might struggle a bit. But yeah, we spun it around the origin, which is this point. So it kind of kept its distance, but that's what happened. So pictures can be a little weird when they cross into different quadrants. C prime, D prime. All right, so let's collect our data. We're at 3, 1. And down there, we're at -2, -5. Okay. what happened? And this is kind of our last coordinate rule that we're going to have in our table. I definitely sense a swap. Like you can see the 1 and the 3, like they switched places. So I know that the y is going to go here and the x is going to go here. In terms of the signs, it seems like the y stays y. And the y stays a y. There's no sign change, but this -1 and this 5, they do get their sign flipped. So I want to bet that that's the rule. Okay. And then kind of like a, hey, let's stretch out a little bit further question. Here we got a rotation around a different point. We are rotating around point Z, which is right here. So how do you do it now? Well, you can't rely on the rules because this is a new rotation point. But we can still do that L shape, but it's just going to originate from that X. So we're just rotating 90 degrees, which, remember, we go like this way when we spin. That is counterclockwise. So I want to take that L and I want to spin him just a little bit that way, a quarter turn. And that's going to place H prime. And we could do the same thing for G. We got that L shape, and then we're going to spin it down and get, it's 3 long, so it's going to be right here. And this one's kind of tough. I mean, this got a lot going on. But it's not out of your wheelhouse at all. That is the rotation around this point. Okay. So G prime ended up at 2, -1, and H prime ended up at 4, 0. All right, a couple more things to talk about. I really like this question. It just tests our idea of rotation and do we know how to perform it kind of in our minds. So if we have M in the middle of a square and I want to see rotate A 90 degrees around M. So if we're right here, remember this is, that would be 90 degrees. It's just going like a quarter of a turn, and we're going, scratch that. 90 degrees is counterclockwise. So we're gonna take it and we're not gonna spin it like a clock this way. We're gonna spin it 90 degrees down here. So the answer to this is D. A ends up where D should be. Okay. What if we rotate 90 degrees clockwise? We rotate this whole segment. Well, if you take that whole segment and spin it 90 degrees this way, you're going to land right there, right? So the answer is CD, line segment CD. Okay, and if we rotate that segment DC 270 degrees, we are going to end up, let's see, we spin this way, right? That would be counterclockwise, 270. We're going to land, if we spin this thing, 90, 180, 270. It's going to spin almost the whole way around, right? And this is going to go to AD. Okay. Real quick too, I mean, if you pick a point, like before and after, you can estimate angles of rotation too. maybe this is about 100 degrees. And that, in this case, that would be, oops, sorry, out of my element. I'm getting kind of lost here. We want to rotate the black figure to the blue figure. So you can say, oh, rotate it 100 degrees CCW counterclockwise. And that could be a way to estimate our rotations with an angle, right? So if we take the blue one, we take the black one here, and we want to spin that up to here, and take this whole shape. Let me get the shape for us. And if we want to spin it around that point, we do something like this, you know, and we track that point. Well, that point went from all the way at the bottom to all the way at the top, like that. That's 180 degrees counterclockwise. And we could talk about quadrants, right? You can put M down here, and we want to rotate it 180 degrees. Well, minus all the details, it's going to just spin like that, right? And it's going to land in quadrant 2. This is 1, 2, 3, 4. And if we plot T and spin it 270 degrees, which is just 90 times 3, we go counterclockwise. So 1, 2, 3. It's going to land somewhere in here. Somewhere in here. Also quadrant 2. Okay? So every time you rotate 90 degrees, you skip a quadrant. And then I won't touch a lot on symmetry, but just because I think we can naturally kind of see symmetry, like we know it's symmetric there, we know it's there. This one you can fold either way. So that would have like 2 lines of symmetry. And this triangle, if you were asking, well, how many ways can you fold it equally? You could fold it like that. You could also fold it like that, or like that. So this one has 3 lines of symmetry. And you can also rotate objects that way as well. And we have a way of tracking that. But for the sake of time, we'll just stick to what we have.